Hey, welcome back to my channel, Math Science by Daniel Dallas. So today I'm gonna go a little way from GCSE, and what I found recently, it was an Oxford Mathematics admission test. It's pretty fresh. That's Wednesday 30 October 2019, and I opened a new series dedicated to solutions. So here guys, you'll have all detailed explanations for how to cope with this sort of problems. This is mathematics admission test, and that's for candidates applying for mathematics, computer science, or one of their joint degrees. And the primary university considering those candidates are Oxford University, Imperial College London, and University of Warwick. All right, so I started work on the problem type A. And the problem is basically you have an equation x cubed minus 300x, and let's say that's equal to 3/7. All right, that what exactly you can find in the link below in the description. You can download this page, and also you can watch the short video with short explanation, but here I'll give you in full in detail. So you'll have lots of details here. So actually it will help you to cope with similar problems. Okay, so let's get started. So what do you need to do? You need to basically define how many solutions, okay? You don't need to solve that. However, you need to define how many solutions does this equation have, all right? So my recommendation, you can consider, if you transfer all to the left side, you can consider as a polynomial power 3. Just remember, polynomial power 3 is a structure as the following: x cubed plus b, x squared plus cx, and let's say plus d. Okay, that's polynomial power 3. So, but I don't want to transfer 3/7. I want to consider basically two parts of the equation as two functions. So function 1, y from x, is basically p3 from x, and this is cubic polynomial x cubed minus 300x. And so right side, y2 from x is simply a straight line, which is horizontal at the level of 3/7. All right, why I decided to choose that approach? Because I just simply want to consider this graph, because it's pretty easy to build and to sketch it if you want to have graphical solution. If you want to do it just simply using calculus, using differentiation, you can do another way. So I'll try to show it both ways. So the first, I just used the p3 from x as a graphical polynomial. So how it goes? Just let's remember general properties for polynomials. So we might have the maximum power xn, let's say decreasing terms, n minus 1 coefficient, n minus 1, and so on, right, up to 3 coefficients, let's say a0. So what about pn from x? So what the main properties? And actually all this task is based on it. So first of all, you notice that if n is even, let's say you can test on parabola, let's say p2 is sort of ax squared plus something something. So, or is x4 plus bx cubed and plus something. So basically you take p4. So in both cases, when n is even, the general behavior of polynomial with even power is sort of that, okay? It means it goes down from infinity, oscillates several times, and number of oscillation is just one less than the maximum power of polynomial. So for example, for p4, it will oscillate just only 3 times. So it means that it would have, local minimum, local maximum, then again local minimum, and goes the way back. All right, so 3 times of oscillation, or just 3 local critical points. So 1, 2, 3. So in P2, you know, it's just parabola. It should have just one less. It's again just one extreme point or critical point, and this is like local minimum. So in both cases, you know that it also depends, so the behavior also depends on the leading coefficient. So in this case, the leading coefficient is more than 0. In the case if it's negative, so your graph would just be reflected downward. So basically it's sort of this way. I'm not going to reflect because, you know, other coefficient might be like others. It does mean that I consider minus Pn from x. I just consider that An is negative in this case, and it goes down. So from negative infinity, it goes up and then goes down to negative infinity. But you understand the general behavior. However, in our task, we have P3. So that's why let's consider, in contrast, how polynomials of the power n, which is now, in this case, odd power. So we consider Pn from x, and we put the same writings, n xn plus n minus 1 xn minus 1, and plus the rest part, a0 in the end. But in this case, I would specify that n maximum power is now odd. So just remember about cubic parabola. So if we have P3, and this is exactly our case, it should look like goes from negative infinity, then it oscillates and goes again to positive infinity, so upward. So you see, in this case, it turned back where it comes from. In this case, it covers the whole range from negative infinity to positive infinity. If there are no like specific, you know, points, when there might be, you know, gaps or some points that might be excluded. So this is not the case. So you just simply do the following. So you again trying to figure out how many oscillation or how many local critical points you might have. So just simply write 2. That's the gain rule. Just one less. In this case, 3 minus 1 is 2. Okay, and general behavior like that. So what if it's this is for leading coefficient an more than 0, all right? What if it's negative? So your polynomial graph will look like this instead. So that's for an negative, okay? And again, but the rule of oscillation, number of oscillation keeps the same. So, okay, we understand that it's sort of oscillation. Okay, just have a look now at our case. So we have x cubed minus 300x. So obviously I just erased the space because I need the space. Space is always critical here. So let's just imagine how it might go, how the graph might go in this case. So we definitely have maximum power to be odd because it's P3. So that's why we do the following, and leading coefficient is positive. So x cubed minus 300x. So we actually wanted to establish points of x-intercept. Because we've got an equation P3 from x cubed minus 300x, we can equate it to 0 to find zeros of function, right? So we're basically saying that we want to determine x0. So we want to find, you know, x-intercept for x-intercept. So what we can do, we can simply do the following. X cubed, we can factorize. So x squared minus 300 equals 0. So from here, you know that x1 is 0 and x2 and 3 is just plus minus square root of 300. But actually you can simplify in this way, plus or minus square root. So 10 goes out and just 3 left inside. All right, so we established basically three roots, right? So 0 and plus minus, all right? 10 square root of 3. So now it's the right time to build it up. All right, so let's restore this graph. How it should go. Y, let's say X. So this is 0. This is 1 point, but it also goes through negative 10. Let's say it's here, 10 square root of 3, and here symmetrically 10 square root of 3. All right, so your graph goes something like this, definitely. Okay, so actually we need to solve equals to 3/7, right? Because the right side, we're looking for intersection between two graphs, y1, this is y1 actually, or p3, and we're looking for intercept with 3/7. So that's why we might have 3 possible scenarios. So I put the red for the straight line, horizontal straight line, and I just do the following. So 3/7 might be somewhere here, right, below this maximum point. It might be exactly through, and it might be on top of that. Let's define our possible scenarios. Scenario 1, scenario 2, and scenario 3. So, and this is scenario 3. Okay. We need to test each scenario because actually we need to find and answer the question how many solutions. We don't need to find them exactly, right? You can use it using DGC, right? But in this case, you don't need to, you're not allowed to use DGC, so that's why you're not allowed to use graphical calculator in order to sketch that. So in this case, you need to think analytically, and obviously we just need to simply estimate this maximum point, right? So this is the maximum, local maximum point. So first of all, let's find xm, which stays for x maximum. What we can do, we can apply calculus. And actually, if you apply just calculus way, I just gave you recently a full picture how it be graphically. But if you simply apply calculus, you can solve it, you know, within several seconds, maybe just within several minutes. Okay, let's try to figure out derivative of y1 prime from x. So in the local maximum, tangent is horizontal, so it should be 0. All right, so let's take derivative according to the power rules. So we'll get 3x squared minus 300, and we equate to 0. So obviously from here we'll have 2 solutions for staying for xm, plus or minus square root of 100, which is 10. So actually we figure out that according to max, we don't need to actually right now, we can test the second derivative, but it's apparently seen that xm here is just negative 10. And this is the only what we're looking for, negative 10. Okay, but anyway, we need to know the y level for this. So let's try to find y maximum. So how to find it? We just put negative 10 instead of argument in our y1 function. That means here. All right, so let's do it. And we'll get x cubed negative 1/7 and plus 3/7. So we'll finally get 2/7, right? Okay, so that's why we established that this level is not unknown anymore, and we know that it's 2/7, right? So what about actual case? Which scenario to choose if we know that y2 equation is 3/7? So now it's key key idea is that 3000 obviously higher than the level of 2000. So obviously this will be scenario 1. And that's why you'll have only one point of intersection. All right? That was a simple solution. Okay, so hope you enjoyed, but probably I'll show you another way how to do this. So actually, what we have x cubed minus 300x equals 3000. Let's just apply calculus. Now, without any graphing, let's just apply to our calculus theory, x cubed minus 300x, and I transfer also 3000 to the left and equate 0. Okay, how we can apply our calculus in order to find how many solutions we have. Can we? So we need to find basically zeros, right? But that's actually bad. The transfer, I think it's better to still consider as y1, right? And our goal is to find, you know, local pivoting points or this local maximum. All right, yes, let's apply calculus. y1 prime from x is just 3x squared minus 300, and we equate to 0. So from here we figure out plus minus 10. That actually we recently found. Basically you repeat that step. And now what do you need to do? You just need simply to check y max by plugging plus and minus 10 inside. So in the first case, when you plug negative 10, you will get 27, right? And in the second case, when you plug 10, you'll obviously get, let me see, x cubed, right? That's 1000 and minus, let's say, minus 3000. All right, so we'll get negative 2000. That actually, so graphically, now we can refer to the graphic case. So it's obviously be like with equal distance, I must say, to the origin. So that's why this level is of negative 2000. All right, so what you recently found? You found recently those local maximum and local minimum. So, but you need to imagine somehow that your graph goes like this. And now you see the level of 2000 and lower than 3000. So that's why finally it will have only one point of intersection, because your line y equals 3000, it goes, you know, above the level of 2000. So hope you enjoy my detailed explanation for Oxford Mathematics Examination Test as per Wednesday, 30 October 2019. It was type A. So give some comments. If something not clear, just again drop the comments. I'll try to answer, maybe clarify some things. But trust me, this was the easiest task in a row. At least I feel that. Okay. So there's going to be next video soon about type B, type C, and we'll just keep moving. So all, you know, uncertainties that you still have probably in your head will disappear. Hope you enjoyed. Don't forget to subscribe. So we'll be together. Hope you enjoy. See you.